One of the big issues facing the world right now is a lack of access to safe drinking water. Every year, over 3.5 million people die from water-related illnesses, which would be the equivalent of the entire city of Los Angeles being wiped off the planet every year. One of the main reasons that people are dying is because 884 million people don't even have access to safe drinking water, which is almost 3 times the population of the United States. Part of the reason that it's hard to come by safe drinking water is that the current testing process takes a long time, sometimes up to a week, to transport samples to the lab and back. And so we decided we needed to come up with some way to help speed this process up. And to do so, we created a waterborne pathogen detector that uses the idea that DNA can be used as a conductor. And by attaching half strands of DNA to gold plates, we can detect when a test sample has the same DNA we're testing for. So let's say we're testing for E. coli. We have a half strand of E. coli DNA on our sensor. And if in the water sample there is E. coli, the E. coli DNA from the sample will attach to the sensor, and we will see a current the current going through the sensor drop.
With the bioengineered sensor that we created, we built a system around that allowed for the accurate testing to happen within minutes. Our system uses the MSP430 BT5190 to allow for Bluetooth communication along with the PAN 1350 antenna. This allows us to talk to an Android device that will allow for global mapping where the water sources are infected. On top of that, we use the Texas Instruments OP827, which is their low power, high precision op amp that allowed for accurate filtering. The biggest issue we had was getting accurate precision because the system we're using operates on microamps. And that's what we're measuring is the drop in that, because the idea is that as the resistance doubles when the current or the DNA actually creates a full strand, your current drops in half.
The main part of the project that I enjoyed was the ingenuity that came out of the bioengineering part of the sensor, where they thought about just using DNA as a conductor. And it was really that ingenuity that drove us for the rest of the project.
Along with that, I really enjoy learning the embedded systems part of this project and having a working knowledge that I can now take forward to potentially do my own projects on my own. We'd also like to take a second to thank TI for giving us the products and free samples in order for us to get this to fruition.